الآن يمكنكم المشاركة في مبادرة الأيام الرقمية تحت شعار انطلق بقوة مع جوجل، والتي يتناول فيها خبراء جوجل عناوين جديدة أسبوعيا مثل السحابيات، مهارات من جوجل، أندرويد، فلتر، ذكاء الآلة، فايربيس، ديزاين ثينكينج، مقسمة إلى دورات وورشات عمل يومية بالإضافة إلى مسابقات أسبوعية. شاهد الأيام الرقمية مباشرة على اليوتيوب وشارك رأيك وأسئلتك مع خبراء جوجل، واحصل على شهادة حضور في كل محاضرة تشترك فيها. هذا وأكثر من الأحد إلى الخميس ابتداء من الساعة 9 بتوقيت دبي عبر الرابط المبين youtube.com/gdgmina.
Hello friends, thank you for being here, and thanks for GDSC MENA for GDSC Digital Days. In this session, we are talking about how we can create we can say an application with features of machine learning. And I think we all know what the machine learning and what are the features and how it can bring life to our applications and features that our applications need. For this session, we are talking about creating an object detection application that we train by ourselves, hopefully with the technologies that Google have provided for us. Before that, getting into creating the application, I want to take a look and know what is computer vision in our application and how we use and how it empowers our applications to have more features and we love. First, computers graphics bring the models we have in our applications, the models we have in our application, our storage to image. We know that computer graphics. And after that, we have photography, and it's image to image. We're capturing image and we are showing as presenting as image. And also we have computer vision with image that we are converting to models. We have some image we capture with our phone, we are taking from our gallery, and we just bring this image or make this image to models to understand, to make our machine understand what we are doing with our image and what we are doing with our program. And computer vision, it lets us the computer and the machine to understand the image and the video. Also, we know that video are images that a continuous image together. So computer vision is the understanding of image and making the ability of computer to understand the image. For example, we have this what kind of senses: environmental, technological, outside, indoor, or is there any car, or what's included in the image, and how far the building, how far the cars, how far the floors. So vision, computer vision, it's really hard because if we look at our human body, 50% of our brain is visual cortex. Our brain consists of 50% consists of visual cortex, which is our ability and the part that takes responsibility of our visuals and things we see. So our life's more dedicated to see things. So the powering machines to do such things is one of the things that we need to bring our applications to life. There are a lot of things that make us to think about we need that computer vision. First, that safety. We can use computer vision to we can say make our lives easier and decrease the disasters. For example, we have car disasters on the road. We can use computer vision to detect the we can say the percentages that a car accident might happen, or we can use in a health to make digital image analyzing and finding, for example, this image we have, it's automatically detects cancer, that if it happens or not. Also, we have Google has a model for detecting eye illnesses, which detects more than 200 eye illnesses just by taking a picture of your eye. And also security issues, comfort issues, because robots, we know that they tend to make our life easier, and they work on computer vision because they should know and get the understanding of the environment, and after that working on that environment. And also we have gaming, augmented reality, virtual reality, mixed reality, extended reality. So they're bringing more interactivity to the games we do, and we have access and control things like that for security. This history about computer vision is not important to focus on coding now in this example. Computer vision, we have a lot of ways that we are using computer vision. One of them is optical character recognition, OCR. We all know that we have intelligent applications that we can easily make OCRs with, which reads the handwriting and extracts to computer writings. And also we have face detection, which we use in securities, in digital surveillance, and we can say accountability for our softwares, and a lot of these things. And also, what was one of the features that people loved that we, I think, firstly we saw in Galaxy S3, which it captures image by detecting your smile, and this is happened by the power of computer vision. And also now we are making 3D image with the 2D image and things we are getting around us. And also we have object recognition. One of the things that we are working on this application is to recognize objects, and that's very helpful. We know that what are the stories of it. And also we have vision-based biometric. I think most of us know this girl, which was it's popular by the Afghan girl, which captured by, I think, Macken photography from National Geographic Abu Dhabi. After 17 years of publishing her image things, people love to know what happened to her after these years. So National Geographic Abu Dhabi went to Afghan, to the place they took the photo, because they didn't know the name of the girl, the tribe, anything about the girl except the place that they took the photo. When they reached there are a lot of people with green eyes tending to be that girl, but they used vision-based biometrics to exactly find the human they need, not the people that says we are him or we are her. And also we have login without password. We know that we have biometrics, we have face detection, face recognition in our applications, in our mobile phone. It's powered all by a computer vision. And also we have shape captures, one of the powers that 3D software is now working on it to make 3D sculptures from human faces. And there are a lot of places that we are working to have computer vision, one of the most popular thing we have seen, but we haven't thought about that offside in the games, in football games, it's powered by computer vision, and also smart cars we have, it's all powered by computer vision. So, how to create a computer vision application, or what are the ways that we can create a computer vision application? In this session, we are creating a simple image recognition. Before that, we should understand how machine learning based applications are working. What are the models, how we are working with models in machine learning. Firstly, we have a lot of platforms that we can create applications with OCRs, applications with object detection, object labeling, image labeling, text scanning, things like that. The most popular that used today is Google ML Kit. It's one of the most popular, I can say, machine learning kits that we can use to power our applications. They have abilities for barcode scanning, face detection, image labeling, digital ink recognition, text recognition, object detection and tracking, pose detection, and selfie segmentation. And hopefully they have the ability, everything that we need, because before that we have Firebase ML Kit, but we had Firebase ML Kit, but after that Firebase ML Kit has been deprecated, and they use Google ML Kit as their main platform, and it's easy to implement with Flutter. And as I go through, I found a lot of we can say sessions, tutorial things with integrating Google ML Kit to our application. So firstly, I try to integrate something different, create something different and easier. I think it's easy and gets the logic of working, how the object recognition apps working, and computer vision based apps are working. So I will use TF Lite, TensorFlow Lite, and Google has created Teachable Machine, which is one of the, I think, most lovely sites to me, because it's so easy and helps you to get the exact logic that you need. This is all you do to create a model, a machine learning model. The first thing is that we need data. To create a machine learning based app, always we need to create data. We cannot create anything without getting data, because we should teach the machine, get the information and understanding how the things are working and what they should search in our image. If you look at this page, we have, if we look at this page, we have this video that is lively detects what's going on in this video, in this picture. How does machine learning knows about the information, or knows about how to create or how to recognize the image? Firstly, before talking about that, we want to, I will go to Kaggle to bring a data set to work on it, because we cannot create a machine learning model with just having a small data. We need at least hundreds of images to create our models efficient. Just 100 of image, just to things like, I think it's not more efficient, because for creating an efficient app, we need more than this kind of numbers. Firstly, we are going to Kaggle. Kaggle have a lot of data set. We can work with it, and the one we are working, we want to detect people's face, detect people's recognition. So we are searching for persons to get the data, customer personality, or we can go with celebrities. Image. Yeah, this is pretty good. It's not so much. So we are downloading this data. Let me sign in. I have forget my password. I think. Oh, so I can do is go with another account. So, okay. We are going to download the data to get the data sets and the image, all the image we need. After that, this is our file, and we are extracting the files. And this is what we get: name of the person, and pretty good image, 119 image of this person. So I think it's a good data set to train our models with. So after that, we are going to Teachable Machine, and in Teachable Machine, we create classes. Firstly, we have 4 person, yeah, but we are working with 3 of them. We don't need them all. First is Kane Wilson. Kane Williamson, I don't know him, but we are writing his name, so we need this writing to be accurate, because after that we are extracting these labels, and each image we are recognizing with this label's name, it should be same, so we need accurate names. And after that we are uploading. We can do just like that. Upload all the image here, and it's uploading. And second one I think it was Cristiano Ronaldo, and we are uploading the image of Cristiano Ronaldo, and it's okay. Now we can train our model. Let me update the third one. Brandon. Okay, the name. Yeah, this is our data set. So we have created our data set. We have collected our image, and how it's working with this image. If we look, for example, this image, we have a white background, and we have a person as a foreground. There are a lot of future pointers. Future points are the pointers that our machine looks for to find it when it uses recognition, or another time when we give an image to recognize it. So it compares the future pointers with these future pointers. So the images that have more future pointers are more better to applications or to training the models. After that, we are going with training. In training, we have advanced, which there are 3 things we can change it. First, we have epochs. What our epochs mean is that 50 times the training went through, for example, Kane Williamson. It searches the image or takes the future points of the image 50 times, not one time for an image. It's 50 times. So if we make it more, it will be more accurate, but it needs more time, and maybe the efficiency would decrease. So we should have a kind of balancing between it. What's the batch size? Batch size in here it explains that if we have 18 pictures and this 18 pictures, and you choose a batch size of 16, so it divides 18 by 16, so it's equal to 5 batches. We said that all the 5 batches have been fed through the model exactly when epoch will be complete. It creates, we can say, group is that when the epochs finishes, it extracted all the features in this group. So as soon as we have more batch size, we have more accurate future point. As I said, it needs more memory, and sometimes the efficiency would decrease. And learning rate is the rate that is learners changing a bit of it, it changes the whole process and affects the whole process. So sometimes 0.001, I think it's a good thing for our application, but more, I think we need more for medical models. After that, we just press train. So we are training. And we are waiting for the training to be finished. Yeah, our training have been finished, then we click OK. Sorry, it hasn't been finished, it just collected everything. We said we have 15 batch time, so it makes 15 cycle to all the image we need. So the 15 should be finished. Okay, after that we can export our model, and we have something else. We can test our application. How we can test it? Just through, we can use our webcam. I have disabled our webcam, it's okay, but you can go to with our webcam or our files, make it on. We have already these pictures, so I don't test my application with these pictures because I have these pictures. It's easy to find. So I will go to with a picture of Ronaldo, Cristiano Ronaldo, and let me see if it's reading it or recognizing it or not. Let's save this picture and give it to our application, our model we have created. Let's go to the picture. As you see, it says 100%. It's Cristiano Ronaldo, and it's don't know the pictures we have worked with. So let me go with another one to see if it's okay with just Cristiano or with everyone else. Yeah, I think we don't have this in the pictures, and there's another person, so we can check the accuracy of it. Okay, it was not a picture, it hadn't been saved as a picture. Save. Yeah, this is, and this one a hard picture because we know that there's another person and half of his face have been covered. So let's try. As you see, it's all 66% is Cristiano Ronaldo. So it looks wrong. But unless we give more pictures to our data set, we get more accurate results. So as you see, 100% co-brand. And let me choose someone else to see is that recognizing, or it's say just 0. Let me go with Elon Musk. As we see, it says 82% like Ronaldo, Cristiano Ronaldo, and 18% like Cobrand. If I add another class and add Elon Musk, it says 100% Elon Musk. So as much as you create more, import more data sets or import more pictures of your data or your objectives, you get more accurate results. So let's export our model to work on it with Flutter, and this is our model, and we are downloading my model, and we are waiting to finish it. It took some time. While it's downloading, let's create our Flutter application. Flutter new object and application. Select the folder TensorFlow Lite. And so our application has been created. I am using my mobile as an emulator. So I use Beazer to let you see the application. Okay. Let me run our application to make everything working. And let's create a simple image picker app to pick an image, and after that displaying the features with TensorFlow. So firstly, we are creating a stateful widget. We need a stateful widget because our application are changing and the state continuously, and my app. And after that, we are creating a material app here. We are returning a material app. So, and we are returning a scaffold. In the scaffold, we need an app bar. Okay, let's create the app bar, and it should be app bar, title, and text. This is our app bar, and we say image recognition or image labeling app. We have created an app bar. So after that, we need a body, and in this body, we just let it to be a container, and after that, we are giving with it. With the thing should be done with it. And after that, we need two buttons to import image from gallery, and also let me maximize or zooming my codes. And after that, this is my application. Let me refresh it. And where's that saying? My app's not a subtype of this yet into typecast. Testing servers. I have returned the material app and it's working my app. Let me create a stateless widget. and this will be my app, and I will return a container here. It's working, but why it's not working for a stateful widget? Stateful widget, my app, and returning a container here, container. I haven't seen this error before. Let me go with a stateless widget now. For now, my app, and we are creating home page here, dot, and we will have a stateful widget in here. Let me rename this one. Yeah, to be a Dart code. So stateful widget here, and I will call it homepage to see if I will get the same error or not. Return a container here. Okay. Let me check this one. Return a material app. Return material app. Say the same thing. I don't know why. Yeah. And this is. Let me make it this. It's working fine now. Yeah, it's working good. And in this home page, we are returning home page. Okay. And in here, we will have a scaffold. In the scaffold, we have an app bar, and this app bar should be titled with text, and the text should be image recognition. App. So it's okay now. And we will have a body, and let's do the container for now. And after that, we need two buttons for adding pictures and from camera and from our mobile gallery. So for that, we are creating a floating action button. I think it's a good button. So floating action button, we need two buttons. So we are creating a column, and in this column, we would have two floating action button, and this floating action button would have an icon. So let's go with, and the icon should be icons.camera. I think we have camera icon dot camera. Yeah, I love outline it. Float action button. Yeah. And this have an unpressed method. Let's initialize it, and we will give unpressed method later. Let's copy it and create another for camera gallery. So this will be a gallery. think it must have, yeah, browse gallery, outline it. I love outline it. Icons dot gallery, browse gallery, outline it. So we have the two buttons, but they are on up, so we should create on the bottom of our page. So we have a column, so we just give a main axis alignment. So because a column, I'll make axis alignment to the end. It's working fine. Let's have a sized widget, sized box widget to give a space to our application. I think 20 would be good to between our two buttons. It's working fine. So we need to have to pick image. So the most popular package for picking image, it's image picker, and it has been renewed, updated recently. So there are a lot of deprecated methods that you can see in applications, old applications that have been deprecated and changed away. So we are gaming with the newest version. And this is our application for installation. If you have iOS Mac devices, you need to add this 3 to your runner info plist file, this 3 permission. For Android, they have automatically done everything, so you don't need to change anything. But before that, you need to also give permission in Android. But now you don't need to change anything. And this is an example. For installing, the way that I'm using is just Ctrl-Shift-P or Command-Shift-P and added the dependency. So we said image picker. We need an image picker. And after that, yeah, this is our image picker file. We have, let's check our pubspec.yaml to see if it's added or not. Yeah, image picker added. So let's go to our home page, and first we are creating 2 variables. One for our file, the path of our file, and we are creating to check in if it's not a null or not path. And this file needs dart.io. And be sure we have dart.html and io, and be sure it's io, not HTML. That's important for image picker for the recent update. And after that, we will have final to pick image. So we make it to be private and pick image and equal to image picker. Yeah, it's equal to image picker. Let's add image picker, and after that we are creating 2 methods to pick image from it. One pick image from camera and one pick image from gallery. You can do with 1 method, but I prefer doing with 2 methods. But you can do with 1 method and create a boolean for it. I will show you how to create this that one too. So pick image camera. So we are picking image from camera. I have changed my keyword, so the characters have been changed. And this should be async nervous, so we are making async. And after that, we will have a final X file, and also we are checking to if that's null or not. And we named our variable to be image. and awaiting, because it's asynchronous, we should await for our picture, and we use our picker image picker variable, pick image, and this pick image don't have a function dot pick image. Before that it was get image, but now have been deprecated and it's pick image. We can look at the documentation of image picker, and you know that we have picket file image.y, but it's not X file, so that's why we use the X file, and it pick image and it was get image. So there are things that have been deprecated. It's better to look for it. And so we have image source. On image source, it will be image source and dot camera. It's all we need, but after that we must make a set state. Before that we are checking if our image is null or not. So we have image, lettuce. We should make it to check is that null or not. Writing null. So if our image wasn't null, we should take the variable to take the image pass to this variable, the value of the image pass. So image pass equal to file, and in the file we have image dot, and we have the path of the image. We don't need this one. Okay, this is our image, but we should have it on a set state. Set state. Yeah. So we have created a method for picking image from camera, and we are creating another method for picking image from gallery. Just we are changing this image source from camera to gallery. So all we are doing. Yeah. The steps are the same, so we are doing like that. So we have our image picker methods. You can do with one method, just making a pick image. We are writing a boolean here, for example, is camera, and we are checking in the source. We are checking if the camera, for example, is true. We are checking if camera is true, and also we are making a ternary application. If it's true, image from source.camera, but if it's from gallery. So we can do like that, but I prefer creating with different methods. Okay, so we should show our image in our body. So we have a container. In our body we have a container. We must check if that our image is null or not. We are creating a child for our container, child, and we are checking that our image path is null or not. Image path, if it was null, I will have a text file to tell me that there's no image. There is no image. Okay, and after that, if it's not null, we have image data, so we are showing the image. So image.file, and our file, we have file, and inside our file we have path, and our image path dot path. That's all. We have const modifier. we are making like that. Image.path. We created everything. This is our container, our file. Should be, yeah, we are checking, so must be something like that. Oh, I have spelling mistake. It's okay. Let's just test our application. Sorry for that. Okay, we don't have any set state for our button, so in set state we are pick image camera, calling pick image from camera, and for this one pick image from gallery. So let's check our application. It's not working. Let me have a refresh because we added package for our application. Yeah, let's check the code. Final pick image picker, and we have asynchronous method and x file await to pick image and source is image source dot image. We also, if image is not null, we have set state image path equal to file, and okay, everything is fine. Image not null, set state. So let's check our floating buttons. The problem is with our floating button because it doesn't call the method. We have set state. Our problem is that we haven't. No, it does not also set state. Let's just find if that's working or not. No, we don't need a set state for. Let me just run application. It's okay. No, file lowercase. Yeah, it's working fine. Our application, it's working. Our image, lettuce. Everything's working fine. So let's go to implementing TensorFlow. We have yet implemented our TensorFlow Lite. So let's just check. We don't have time. I think we could not reach our time, but hopefully I am working on it. So this is our TensorFlow Lite package, and it also have an amazing documentation we can use. This is object detection we can use. Our object detection things. This is run on image. We are speaking about it. So let's go to install our TensorFlow Lite. For installing TensorFlow Lite, you have to do something in Max to clean your application. Run Flutter clean, but in Android, it's fine. So, and it's not about TensorFlow Lite cleaning your application. It's about what we call another package that we need, and it's called Meta. Okay, this package we use that are shipped with Dart SDK. It defines the annotations. We need this package for our TensorFlow. Let me install also Meta. So in Apple device, if you encounter any problem, just run Flutter clean. I think everything would be fine. Yeah, let me check. We have TensorFlow or not. Yeah, TensorFlow, and we have Meta. And let's go to the model we have created. This our model. Finish it, and yeah, our model have been finished and downloaded. So let's extract our model. While extracting, we will have two files. First one is the labels, names of the class. I said it should be exactly the same. And the second one is our model. For that, we need to create a folder for assets. And in this folder, just drag and drop these two files to this folder. And after that, in popspec.yaml, we are using assets. This is most like it. Okay, and assets, and the first file is labels.txt. This is, we can write this. Yeah, labels.txt. And the second one is assets, our model. So this is the two assets we should include in our application. So for initializing TensorFlow, we are creating a method here, and this method to load our model. We name loading image model. We are loading our image in this method, and it should also be asynchronous. Let's go with it. We will have a result, a file, we call it result. Okay, results, and this file equal to our TensorFlow, awaiting for TF Lite dot load model, and let's add TensorFlow package. Okay, our model. So in our model we have two things. One was our labels, and for defining our labels, just go to assets, copy it. That's good. And we have another file which is our image, or we can say our models. the things that we are reading on it. And we also copy paste this one to our application. So we have created a result variable, and we have loaded our model, and we have loaded also our labels. And after that, we just make a simple print for our understanding. Result is results. Just for understanding, it's not important. So we have used asynchronous, and we have waiting for the method, and at the start of the application, our model should be initialized. So we must have an initiate state. We must have an initiate state. Okay, so we are creating an initiate state. It's good to be here. Yeah, I will just define here initiate state. It's not auto-completing my writing. It's not important. Init state, I think it's like something like that. Yeah, it's good. And we make it void, and we now it must be overridden. It's we must have an override method overriding this method, and we must have a super initiating state, the super, and also our loading model should load on the start of our application. So after that, we are creating some variables, and this variable, for if we look at TensorFlow package here, yeah, so we have something. We have image mean, image standard deviation, image result, image threshold, all image path, and we have something else: image height, width, number result, rotation, model also. So we should create some variables for them for storing this information. I'm creating a list to store the results we have because sometimes, as we saw when we gave Elon Musk his image, it gave me thinking that's Cristiano Ronaldo, but and also a less probability thinking that another person. So sometimes you have a lot of image, a lot of persons. Not sometimes, most of the cases, because this is just for testing purpose, not for something else. So most of the times you have a lot of classes, so you need to store them on a list. So we will have a list, and we call this list, we can be, it can be result. It's good, and it's empty. It doesn't equal to anything. Let's to be like it, and I think it needs a Lite modifier. It's okay. So we will have another string to writing the confidence, how much as we have tested our application, we saw that there are a confidence level. So what is the confidence level of our application? So string confidence, and this should be and we have a string for the name, name, and also it's equal to a space, nothing. And also we have a string for number, and it's also empty. Yeah, This is our for variable. So we should now have a model to apply our model. We are creating a model before this for applying model to the image. So apply model, apply image model, naming our method. So we have what in here? We have a file. So we have a TensorFlow file and it's a file also. It should be a file. So it also must be asynchronous because we need the data. We will have a variable to store our result in it. So I name it result. We have a result here and a variable to store all the things, all the information we take from the image. And we are awaiting for our TensorFlow run model on image. We have TensorFlow Lite dot run model TensorFlow Lite don't run model on binary, on frame, on image. So we need on image, and we have a path. Our path is our file dot path, and the file that we are passing to this parameter. So file dot path must be our path to the application. We are just not storing paths. We have a lot of things. We should identify them. We have after pass, so we should have a comma here. We have num results, and this too, the number result of, for example, we have 3 person here. You have a lot of person. How many results? For example, it detects it have relationship with 2 or 3 or 10 classes. How many classes do you want to show in here? So I need 2, and the threshold is the threshold of our image. We have 0.5. I think is good. And we have image mean. We all know what's mean. So also 120. Let's to be like that. And we have image standard deviation, as I mentioned, and we looked in the package. We have standard deviation also. Yeah. And after that, we must pass this variable to, we must have a variable to pass the information of this variable to it. So we will create a set state, and we are passing result to equal to res. Okay, we haven't defined this. Okay, sorry, we should pass this variable to our list. Our list name was res. I will make it to result to not be confused with the other one. Okay, so it should be good now. Yeah, and this is just checking null because this thing is should not be null. So what have we done till here? We have created our model, we have loaded our model, and we have applied our model. Okay? And we have 2 labels. So we want to write the labels we have. So we are getting the labels after passing variable to our list. We will have a string we call str, and it's equal to, we have result. Now we pass we have all the variables in result, and we start from 0, and this will be my labels. So label, if we look at the TensorFlow file, label text labels, so good. And in this here we have labels. Yeah, we are writing the labels now. It's good. And also we have names. We are writing the names and other things. We have name. What was the name? Name. Yeah, we can create to be private. Better, I think. Yeah, we make it to name, and this is equal to str, because the variables are now in str labels. We have str dot substring. We have two variable 2, and it's good. And we have confidence, and this is also, we need a null check here. First result, we are checking it's a null or not. Result, if it's not null, to have what? Result, and the first result of the first label. We are returning the result of the first label, and with the result we are returning the confidence of this label. Confidence of this label. Okay, so the first one, if it's not null, we are returning the result. To be more accurate, when it returns the result, it returns with 0. For example, 0.6, 0.6, things like that. So we can multiply it to get more, we can say, accurate. So just multiply it by 100, because 100% based off 100%, and we change it to string, because when we are multiplying it's double, and we need to have it as string. And then we will have as we will have a substring as the one before, and it should be,
I didn't understand that.
It should be between 0 and 2. For making more efficient, we can write 100%, things like that with it. Something, I don't know why my keyboard have been changed. If it's null, we can just bring something null like that. We don't need to retrieve anything. So if it's null, we are just showing an empty file. What's that? Okay, my file homepage. Yeah, sorry. So we have finished writing the confidence and writing the names. So now we should write, and we should show our result on our page. Let's just restart our application to start from 0 and go to our container. We have an image text that it's null when it doesn't show anything. And let's to have something in here. After the image file, we can have a container. This is our image file. We can have a column, and in the children we would have this and a text. We are writing a text with name, and also we can have a text with confidence. Okay, or we can write both together, not to indifferent. We can write in same and name equal to what was the name of our, when retrieving the name of our label with this this variable. So, and after that we are going to another line and we retrieve confidence, and it's also what was confidence. Yeah, we had confidence. This is how we can show our application. Okay, let's work on it, if that's working or not. Yeah, it does not retrieving anything because this is not the person we are working with, and we don't have this in our database. Let's have this image on the model here. I don't have it on my computer, so just I screenshot it and working. Oh, sorry, guys. Yep, it's working. Everything is fine. We have load our model. You can test with your models with the ones Cristiano Ronaldo and the people, because I don't have, I think, any picture of them. So you can work on it and test any applications, any image. We have created our load model in TensorFlow. We have a variable to store our results, and also we have an apply image model which we retrieve, and we just put down some restriction to our retrieving image from our application. And also we have what we call, we have some variables, a list to store the result, a string to store confidence, and we have name to store the labels, and we could have use number to store the numbers of the labels, that classes that we are retrieving. But okay now, and we did apply image, and we also have a set state to just give the values of in the result variable we have, and writing everything. And when the image is loaded, we have a text to take when our image is loaded, our image file is loaded, and everything is okay. It's working fine. So I have finished everything. So if you have any question, you can ask. Thank you for your time, and sorry for being late. But the thing is that more important to understand, especially understanding the part that machine learning working and the feature selection and working on the models with the data sets, how to create, how to select the best data sets, and working with Teachable Machine, I think will be one of the great things that you can work on it and you can empower your applications, and it's amazingly good. And you can integrate the TensorFlow file Lite to most of the programming languages. Thank you for your time, and I am here for your questions. I will share the code in my GitHub, and I will post on the comments of this YouTube video. So you can have the codes. I will share it now, just right after the session. Don't we need to ask for permission before accessing gallery and camera? Yeah, we need to ask permission before accessing gallery and camera. As I mentioned, in Apple devices, you need to integrate some codes to your info playlist, but in the newer version of image picker, in the older version, you need also for Galaxy, for Android, sorry. But now you don't need. But while you are running on your application, it needs. So it's the newer version of the image picker. Believe me, firstly, I knew tonight that they just released a newer version, and I just look at the code and I just tested in this session the new image picker, because previously it wasn't like that. It was a bit harder, but we just went through it and it was good. And thank you for your time. I don't have anything left. I will show you the code exactly after the session in my GitHub, and I will post the link in the comments. Thank you for your time, and goodbye.